Hello all, welcome back to Project Mastery Podcast. Model evaluation is phase 5 of CPMAI project. What do we do in this phase? Once a model gets created, you will need to evaluate the model. You will need to ensure it is performing as per the business expectations and as per other standards which have been set in phase 1 of CPMAI project, as well as other factors which have already been discussed and defined as part of user acceptance criteria for the particular sprint or for the particular iteration. Model evaluation means you are going to perform model metric evaluation, confusion metric calculations will happen, KPI metrics, model performance metrics need to be evaluated, model quality measurements will happen, and finally you are going to determine if the model is well suited for meeting the iteration goals. Let us get into each and every concept and see how we need to ask questions on these concepts. When we talk about model performance, we want to know what is the model doing? Is it doing what we have expected to do? Is it the best fit and is it well optimized? Is it giving the best generalization performance? Are we tuning the models? What approaches are we using to tune the models? How about configuration decisions? Are they being recorded? Are the models performing as desired by us or as desired by the project? How about accuracy? How about performance? How about false positive rates? How about false negative rates? Are we using foundation models or pre-trained models? How are we fine-tuning them? How are we extending them? How are you going to measure the performance of these models? If generative AI is being used, how are you measuring the performance of Gen AI models? These are the questions you need to keep in mind and have an answer when it comes to model performance. Is the model meeting the business and technology KPIs? How are you going to evaluate the model against the KPIs related to business? How are you going to evaluate the model against the technology KPIs? What are the methods in place to improve the model return on investment against business KPIs? What are the methods available that can be improved so that model performance also improves with respect to technology KPIs? When it comes to model iteration, you need to keep the model performing always. This is what is the goal. How are you going to measure the drift? When you say drift, there are two types of drift, model drift and data drift. How are you going to measure the model drift? How are you going to measure the data drift? Model retraining is going to happen. What approach you have taken to retrain the model? What are the training pipelines? What are the data pipelines that you have created for model retraining? What are the situations where it will be required for your models to be replaced? How are you going to iterate Gen AI approaches? How are you going to iterate fine-tuned foundation models? How are you going to iterate the extension of pre-trained models? These are critical questions that you need to have answers for when it comes to model iteration. Is the model giving you the expected result? How right is the model? Is the model performing wrong? What are the false positives? What are the false negatives? Are the false positives really bad? Are the false negatives really bad? Are the outcomes really bad when the model is not performing well? How about tuning the model? Is the model tuned properly? What are the business objectives? Have we accomplished the business objectives through this model? Model evaluation is an extremely critical step. It is always required to plan for significant evaluation of the model because model evaluation is going to help us extract maximum value from the AI project. Data drift is referred to as data decay or input drift. It's a challenge where over a period of time the data which is being used by the AI system is going to change from its original characteristics. It's going to change from its original understanding to new characteristics. Over a period of time, the good quality data will continue to decay because of increased errors, because of missing values, because of other specific aspects that may lead to poor data quality. Models trained against old data will continue to perform poorly against the real world data as it drifts over a period of time. Data drift aspects include feature drift, where the features of data will change, concept drift, where the input mappings to outputs will change, and label drift, where the data representations change over time. Operation data drift or upstream drift will also happen when there are changes in the way the data gets prepared, when there are changes in the way the data gets collected, or when there are changes in the way the data gets engineered in the data pipeline. Model drift refers to model decay. It also refers to prediction drift. The challenge that over a period of time, the given model that has been performing well against real world data tends to perform worse over the period of time as the real world data or the operation environment keeps changing against the data under which the model has been originally trained. Models can also drift due to changes in the model performance expectations, the ways in which the models are being used or applied to situations that may not be dependent on the real world data. The specific drift is the drift in predictions from the expected level of performance. It refers to the drift in predictions from the acceptable level of performance to unexpected level. When it comes to model retraining, we need to understand that there is always a need to train a model which has already been trained and placed in the real world for improved performance. Model retraining is an approach that needs to adapt it so that you can deal with drifts like model drift and data drift. Model retraining can also be used to expand the scope of the model, and whenever you want to deal with different requirements related to operations or operation requirements, you can make use of model retraining. Model retraining is a very important part of the iterative AI project management methodology, which is the CPMAI methodology. When it comes to model retraining, you need to understand when do you retrain a model. You're going to retrain a model whenever there is a model drift, whenever there is a data drift. Histograms are available. The degree of overlap between the two histograms is going to give a measure of similarity. These are the measures that will help you to know whether there is a drift or not. KS statistic is also a measure. It's going to check if the upcoming new data belongs to the same distribution which was used for the training data. Target distribution is also one of the measures. If your training data set is imbalanced with 99% data belonging to class A and the remaining 1% belongs to class B, the predictions say 90% is class A and 10% is class B, then there's some problem here. Prediction correlation is also going to help here. These are all pairwise correlations between individual predictors which can highlight any underlying drift. You need to understand how often you have to retrain the model. If the underlying data is constantly changing, retraining should be on a regular basis, must be on a periodic basis. You also have an option to use performance triggers to indicate the need to retrain the model. Machine learning models need constant upgrade. Data is going to change constantly, model is going to change constantly. You should always keep your models accurate. Models need continuous evaluation. Models need continuous retraining. You should always focus on development of retraining pipelines, iteration of the retraining pipelines. Retraining pipelines can use the same pipeline that was used for model training, or it can use a different pipeline. One should always keep the 80% rule in mind. Significant amount of time is going to be spent on data preparation, data cleansing, and augmentation. Let's say that you have a practical project being assigned. Key steps you need to perform as part of model evaluation phase. You're going to evaluate the results. You're going to review the process. You're going to determine the next steps. Project manager should validate and interpret the resulting models based on various factors like overfit, underfit, accuracy, performance measures. There are other factors that could even impact the hyperparameter settings. There could be changes to algorithm selection. There are other factors that may require retraining the iterations. You will need to provide a model validation report based on selection and the method of model validation. You need to rank the resulting models and assess according to the criteria set for evaluation. Summarize the results. List the qualities of the generated models in terms of precision, accuracy, performance. Rank their quality in relation to each other. This is what you do when it comes to model assessment or model validation task. When it comes to model measurement, you're going to provide a measurement output from the modeling tools such as learning curve, ROC curves, precision versus recall, and other validation measures to assist with assessing model performance. All these are part of evaluate model result task that you perform. Evaluate the model and produce the evaluation measures. Summarize assessment results in terms of business criteria, including final statement, which is going to cover the fact whether project and model was able to meet the business objectives. You have to measure the model performance against the business KPIs, which have been detailed in phase 1. If the model is not performing adequately, we need to come up with a detailed action to improve the KPI performance of the model for the iteration. Models need continuous iteration if they are not able to provide the desired results, or if you want to improve the results in future iteration, you need to continuously iterate them. Detailed on the approach that's being used to iterate the model to improve on any of the results. You have to detail any approvals that are required, any reviews that are required to be conducted before the model can be operationalized in production. We have covered the key concepts as part of model evaluation phase. We have come to the end of the podcast. Hope the knowledge was valuable. Thank you for tuning in.